Roboticists make great robots, and they have no idea how the construction industry works. But it doesn't change the fact, if you're not a good concrete contractor, you can't be a good concrete printer. If we had houses like this in certain parts of California or LA, we could have greatly reduced the amount of destruction and houses that were lost.
I think the work you're doing is so incredible, but on the other side of the spectrum, there are skeptics.
People want to try something new, but they want to make money on day two. Getting them to fail often and fail small is really difficult. They just don't want to do it.
This is The Build-Up, a podcast by Procon Consulting. We have an exciting new episode for you today. As you can see, we're not here in our typical recording studio. We are here at the Innovation Center at Virginia Tech, at my alma mater. I have a special guest, Professor Andrew McCoy, who's doing some really important work. You can see the equipment behind us, but before we get right into it, I just want to thank you for joining us on The Build-Up.
Well, thank you for having me, Kyu, and I will just correct you a little bit off the bat. It's the Procon Innovation Center, and we're really excited to be here. This is a great space, and it's just wonderful to work within it. So.
Well, I appreciate that. You know, I've known you for several years now, but for a lot of the audience, I thought that maybe you can give us a little background about what you do here at Virginia Tech.
I wear a number of different hats. One hat is that I direct the Virginia Center for Housing Research at Virginia Tech, which is was appointed by the state of Virginia as a housing research center for the state. We help the state with data and studies around looking at the discrepancy really of income and housing options. So another way of saying that is affordable housing. How many people can afford housing at different levels? So we work with localities, we work with the state, we do research that tries to understand different ways to make housing more affordable at many different levels for many different people, many different families.
Speaking of affordable housing, I know that phrase and housing shortage, those things get tossed around. In plain English, like what seems to be the problem?
Well, that's a very good question. It has become more and more complicated over time. So when I first started working in this area in 2005, it was much more an argument around we have so many ways that we can help people have better housing choices. Why aren't we trying to help more people with that? Now it's an argument of not only can we not give people the housing that they need so that they can actually live in a stable environment where they can recover from things like health injuries, or they can be in an area where they feel like they can have access to good education or health care. They're commuting from counties away just to have jobs because they can't find housing that they can afford anywhere close to the different employment that they have. That is part of it. It's become increasingly something that is an issue for our industry, which is we just can't produce buildings fast enough and at a cost that we can afford to keep building for the need that we have. So it's become almost this endemic problem within the industry where we're not able to do what our core mission is, which is, at cost, at schedule, with the quality that is decent for people to be able to have good housing. And so it's grown over time. The way we look at affordable housing, it's a legal term, really. People argue over what it means, but it's a legal term that we use and have historically used that's based on this idea that we should be able to pay 30% of our income towards housing, right? So when you go apply for a mortgage, they ask you what your income is, and they look basically at 30% of that income. It used to be 25%.
Okay,
and
I actually never knew that, 30%.
Yeah, so if we look at the middle income that people make in an area, so if we take Blacksburg, let's just say that, for example, the median income, the middle income, is $100,000. It's not. I mean, that's way high, but still. Or Fairfax, it's $100,000. Then we expect people to pay $30,000 a year towards their housing option, right? Right now in Fairfax, you can't find anything that somebody who makes $100,000 can pay $30,000 towards. They have to live 3 counties away to do that, and then they commute to Fairfax. So they can make the $100,000 in Fairfax, right?
Is that mortgage payments or just?
Increasingly, it's become mortgage plus the energy burden, right? Because it's expensive for energy. It's transportation costs a little bit now because we're commuting, because we are trying to get better housing options in a different location than where we work. If you're a fixed income and you're a senior, then it's healthcare costs, right? So the amount of money that we're asking people to pay towards what results as a housing choice is increasing. It's increasing. So I think that's these ancillary costs are not as much the focus right now. It's the fact that in many cases, 50% of the population, based on rent or home ownership, that are paying over 50%, over half of their income for their housing because they don't really have any other choices. And so we can't produce buildings fast enough. What used to be kind of we need more people and more houses is now we just have a crisis. We have to get more people and more options for more housing with more density. We have to be able to produce it as an industry better and faster and on cost and on schedule, things like that. So that's kind of what we're wrestling with, yeah.
And is that how you landed on 3D concrete printing, or did you have an interest in printing? Give me the backstory
Right.
behind
How does this all fit?
Yeah,
right?
how does this all fit?
So one part of that, which is kind of the other hat that I wear, is in construction management. My background, I was in the industry for a while, came back, did my PhD, and teach in Myers-Lawson School of Construction. And so with that knowledge, one of the areas that we decided to start focusing, so with the housing work that we do, often it's policy, or financing concerns, things like that. Well, we started looking at the production cycle because pretty much we assumed that the direct costs of the building were set, right? Mm-hmm. The industry has been trying to solve that problem forever. You can't really squeeze too much extra cost out of things, and we've heard
margins,
that.
Right.
Exactly, very small margins, right? And so we started saying, well, how can we change the production process to actually be more affordable? Are there technologies that can combine many different trades into one option? 3D concrete printing. We take the exterior walls of a house, which might be 4 or 5 different trades depending on who does what, and we try to boil it down to 1 to 2, right? And it's one type of material, it's one process. If we can make it go fast and have cost parity, if it can be equal in cost to stick framing, hey, maybe we have something here. And I think that's what we've tried to kind of chase down. We've done that with industrialized construction across the board. We have projects in prefabrication.
Yes, prefab is taken off. It was hot when I was here in school many, many years ago.
Exactly.
And it seems like all of the builders are using prefabs.
Right. And if they're not looking into it, they're falling behind. So that's what we've been trying to do. We try to figure that out, work with that kind of equation.
So, before we go in depth on all the different important work that the Virginia Housing Research Center is doing, mm-hmm. Can we just backtrack and maybe just kind of discuss how did you get into that? And how did you land on that role? And what does the Virginia Center for Housing Research, what do they do?
Well, I started off in industrial and commercial concrete work out of school. I went to architecture school. I had a great mentor who said, why don't you come try concrete work for a little while and see what you think? And I loved it. An
important member here at Virginia Tech.
Correct, yes. And I loved it. And that was great for a while. He was, as a good mentor should, kept saying to me, hey, listen, make sure in 15 years when you look in the mirror that you want to be a concrete contractor. That's what you want to do. And I started thinking more and more that a lot of what I loved was the building process and residential. I wanted to try it out. I'd never tried it out. I wanted to try it out. So I talked to him, and he was very gracious. And I left the company, and I went and worked in residential for a while. I joined a crew, is what I did. I joined a crew, and
you wanted to get from the ground. I remember you telling me that.
And then worked my way up to lead a crew. And then the owner of the company said, listen, I know you can do design. Why don't we partner? And then the owner said, I really don't want to do this anymore. You want to buy me out? So that's how that kind of worked, and ran that company for about 4 or 5 years. That's when I came back to school. I had already kind of gotten the bug for residential. I love the scale of it. I love the fact that if you can figure out what works at a smaller scale, it really is applicable across the housing unit itself, and you can expand that and scale it from there. Often with commercial, it can be one-off. It can be very bespoke, and so I ended up, when I came back to school, I got involved with a National Science Foundation project that was looking at two things. One was the spread of technologies across the residential housing market, right? What affects those spread of technologies? And the second was my PhD, which was developing a model for commercializing residential products, right? So how do you track the process that needs to happen so that they're commercialized into the market properly? And then how can you predict, hopefully, good processes around commercializing new products into the market, right? And that led me into working with the center, though, at the time. I was lucky enough to get a position here as faculty. And so I kind of kept a little bit of that trajectory. We got additional funding 5 years later to map county by county the spread of individual technologies across builders. So we could look and say, hey, these products had these factors, and that's what helped them actually spread faster and get market share more quickly. That led us to a study that we did for the state of Virginia, which was around the economic impact of housing and housing technologies. How is housing affecting our state, and what do we need to do to build up our housing technology within the state? The reason for that was Governor McAuliffe at the time was concerned about all the conversations he had with businesses that he was courting to the state, and they would say, well, where are people going to live? Well, and he was saying, well, what are we going to do about this? We were producing 20,000 homes a year at the time, peak level. We're not that much higher now, and we're a good bit higher, but still, at the time they said, all right, well, what if we have a major change in the needs of housing in the state? What are we going to do? So we forecasted different models that would look at the housing demand and the ability for the state to keep up with housing demand, especially if we had an event like the Amazon HQ2 come to the state. We were way behind. And so they started working on a grant program that would help technology that would not normally be introduced into the construction industry because of the risk, the financial risk. The grant program, the goal of that would be to provide the funds that allowed builders to take the risk. And they wanted us to work with builders to kind of implement this and diffuse it, which is a lot of the research I had done before, which is how do you bring technologies into the market in residential? And so in that process, they wanted us to try out 3D concrete printing. So we got our first 3D concrete printer. That was in 2019. We've produced 4 houses now as a result of that. We've monitored and censored those houses. We know how they're performing on a by second or by minute basis if we want to. We can look at all the different ways that we design them to work. We can see how they're actually working, so then we can redesign. And we've wrapped all that together and the partnerships we have around that process into this new grant that they've refunded us to go out and build 10 houses now. So we're building...
In Richmond?
Correct. In Richmond. We're going to build 10 houses over the next 2 years. Yeah, we're starting this summer. That's right.
I think the work you're doing is so incredible. I was just teaching, lecturing one of the courses this morning, actually, and just giving students encouragement about aligning what you do with the impact that you're going to make, having meaning and having purpose, and these are things that seem abstract for a lot of the younger students just going into the early career fields. But I just think what you're doing and talking about residential, talking about creating affordable housing, is such an impactful work. And so I think that's just so amazing. That's the reason why I wanted to have you on this show.
Well, thank you. Back at you. I think the work that you do is amazing. And we couldn't do what we're doing without the support that you provide back to us, which is just, it's hard to put into words how much it means. At the same time, I want you to see what that is doing.
Tomorrow we're going to be doing a lot of the concrete printing, which maybe this is a good segue for us to talk about concrete 3D printing. Could you just explain, before we get into the nuts and bolts, why is 3D concrete printing so important to you?
It's interesting. So I started off in concrete. I've always loved concrete. It's unforgiving. It's tough work. It's time sensitive. You got to get it right. You got to plan correctly before. And guess what? Things go wrong still. And so you got to have backup plans, and you got to know what you're doing. It's just not, it's not like wood. Wood, we can, we'll knock this a little bit here. We'll do that. You have to know what you're doing, and you have to be good at it, right? And I love that about it. With 3D concrete printing, it's kind of taking it to a different level where you're adding a lot of technology to it that you need to also know. But it doesn't change the fact, if you're not a good concrete contractor, you can't be a good concrete printer. You just can't.
For those audience that might be listening, they're like, concrete 3D printing. It
What
sounds like a 3D printer that I think I've seen with
Sure.
plastics and stuff like that.
Yeah.
Maybe we can go there. Like, what is concrete 3D print? I mean, it sounds self-intuitive in terms of like what it says.
Sure. Well, maybe I'll put it in terms of something that, well, some people probably might be too young to know this, but if you've ever had an inkjet printer, really what that's doing is it's layering ink onto a surface for you.
That's a good
right?
example.
It just doesn't have a vertical dimension to it. It doesn't have a Z dimension.
Gotcha.
So then the younger generation is going to know more about like a Faber, where you use plastics-based ink. So what we would think of as ink before, this is a polymer that we're basically heating, and then we're building on top of itself, right? So now what we're doing, instead of the ink that was a plastics-based ink, we're using concrete. And concrete has to be at the right mix and extruded at the right way with the right timing so that you are setting up enough, but still tacky enough in the curing process that by the time you make it back around on top of that layer below it, it's layer by layer, just like what we talked about before, and it's quite precise. We can be very precise with it. But when you make your way back around on top of the layer from before, it needs to support it and bond to it really well. And so you have a whole side of this that's really about the concrete and the chemistry of the concrete and the mixing and the pumping. And so hopefully the system, and that's the system we have here.
Yeah.
All these pieces talk to each other, and they go through a central software that helps us control that. But what you're going to see tomorrow is we're going to do a lot of it manually. Mm-hmm. It's better to know how to do it manually and be able to do it right than to rely on the software for everything.
So is there a design component?
100%. And I would say the big difference that we're probably...
What is the design process like?
Yeah. It starts off as a two-dimensional set of drawings that then we turn into a building information model. We use that so that we can visualize the process, we can understand where the details are going to work, they're not going to work, all that kind of stuff. So we embed the model with a lot of information. We will turn that then into a script, basically. It looks at the surfaces of the building and it breaks them into quadrants. Mm-hmm. And it understands how long it takes to get through one quadrant of the building, then to the next, and you can attach information that allows it to know you go from this quadrant to this one and then print the full and then you go back. But that's relatively rudimentary. Now it's gotten towards the script tells us exactly where start and stop points are within a specific area, so we don't have to see the fact that every time it lifts, it gives you a little bit of a deformation in the wall itself. So we hide that to the interior of the wall. We do things like that. All of that then gets fed into a program that translates it for the specific printer itself, and that's called a slicer program. So before that, we use a Rhino program, a Grasshopper program that helps us write the script or the code. Mm-hmm. And that then gets translated for the printer. It can do that directly, but the slicer understands the limits of this machine and holds you to certain parameters. So
there's an X, a Y, and a Z component.
Absolutely.
That knows exactly how to, based upon a three-dimensional design in a BIM model that gets converted into a script. Is that the way I understand it?
Basically, yeah. It doesn't automatically convert. We have to do that at this point. Mm-hmm. Someday, maybe, if somebody feels like that, there's so much of this on the market that they need to do that. And then it basically has a point of origin, right? So we start from that point of origin every time so that we have 0, 0, 0, and then we can go from there and start printing and make sure that we know what we're doing.
many, many eons ago, I used to have graph papers as part of the engineering
That's exactly
curriculum, and you're giving me trauma just thinking about zero,
Well, get ready
zero.
for trauma tomorrow. Yeah.
So that's exciting. Can you speak a little bit about like the mechanics of it and how it operates? There's an area where, how does this thing print? Like what are the supplies you'll need, and just
Sure.
mechanically kind of walk us through?
Well, so there are different types of printers. This one is robotic arm on a crawler base, is what it is. We call it an RC20, Robotic Crawler 20. And it's made by a company out of India named Tavasta. In the past, we've used gantry printers, and those work quite well. They just have different benefits and detractors, I guess I'd say, to each type. So you have the mix, then you have the mixing, the mixer. In that case, it could be, we have a smaller inline mixer, it's called, where the water comes in, we set the water pressure, we put the mix in the top, and it takes care of everything for us. And it really is a great, great machine. You'll see that tomorrow. You have a large drum mixer that you can use, which is where you have a full cubic yard that you're trying to mix at one time, right? And that just basically mixes it and dumps a large amount into a pump. So either the inline mixer or the pump or the large drum mixer goes into a pump. The pump is a typical concrete or mortar pump that you might see. That it has a large hopper at the top that allows you to dump the mix into it. And coming off of that is a hose. That hose gets connected up to the head, the print head basically. We call it an end effector on the print machine itself. And that's the part that actually has most of the intellectual property, and that's where a lot of the magic happens, right?
Now, can you just put any concrete bags in there, or is there a special kind of mix that you need to put in?
So you basically have a concrete mix that is high in terms of cement content. It has an accelerant in it, so it hardens pretty quickly, right? It reduces the amount of time for curing by, a fifth or a quarter. So you have to get it through the tube really quickly. You have sand as aggregate. You really don't have aggregate larger than sand in the mix.
So these bags, they're not something that you can get at those like big box,
No.
Home
No,
Depot.
they're not readily
Lowe's.
available. They're expensive, and that's part of our project is we're working on material science to understand, can we create mixes
On your own.
Well, we're looking at ways that their mixes can become something that are accessible to local batch plants that they could work with, right?
Right.
And so one of the ways we're doing that is local mining operations. They have a byproduct that's just really fine, basic dust. It's like a very, very fine version of the rock that they're mining. It's 15% of the actual mining process. Well, they can't use it for anything, really. They have to actually mitigate it. They have to bury it or find some way based on EPA regulations to mitigate it. It's expensive. And so they're looking for something to do with that. And so they've been sending us at different quarries, because it depends on where you are, the top of rock and everything like that. They've been sending us that dust to say, hey, can you actually replace cement with this? The cement is the expensive part of this process in a lot of ways. So can we actually start using different byproducts of industries? Fly ash is another good example, which we've been doing for a long time. Can we put those into these mixes and try them? They're not doing that right now in the industry because they're going with mixes that they know will work immediately, and there's a lot of chemistry in it. But in this case, we're hoping that we can kind of take some basic materials and start introducing them into the process.
Can you talk about the value proposition of in the whole, as a general sense, of using 3D printing? Like, what would compel a firm to consider that in the future? I know these are new technologies that you're researching.
Okay, so right now, just to kind of take the air out of the room, it's not cost competitive. It's not terribly the other way. Right now, it's maybe an 8% premium. Some different systems, depending on what you're doing and the designs and all that, it can be 20, 30% premium right now. So I want to be careful to make sure that I'm clear that we are not at cost parity yet. There are some groups that are getting there. They are equal to what it would cost to frame a house, and they're producing these at large scale, and it's working. And they're
But it
saving.
takes trial and error to figure that. So what is the ultimate goal?
Right. I tell people, look, the lumber industry has had 100 years to engineer and perfect their product and their supply chain. We've had 5, in this industry. The overall goal is to produce more durable housing, right? So it's something, if we had houses like this in certain parts of California or LA, we could have greatly reduced the amount of destruction and houses that were lost, right? So
More durability.
I think insurance companies might start driving that, right? So we have one concept that we're working with another group on. It's very, very early stages, but if you took a house like this and you buried it, or you put fire all around it, what does it look like? Buried it in water, I guess is what I was going to say. It submerged it, so you had flood damage, things like that. Can we create the different details that hopefully would help it hold back water, help it to not be susceptible to some of the natural disasters? So I think that's one area, right? It's providing people with a building that they can depend on. The second is the idea that we can be more customized, but we can also build faster, and hopefully then what I was starting off with, which was the cost side of it, we can get down to where it actually is cost effective. Right? And I think we're getting there, but it's not there just yet. At some point, that'll become more and more the conversation of why we want to use this technology. I think the third is that the way that these buildings work and the way that at least we've been designing them, they're more efficient in terms of energy. So they operate...
better thermal properties,
Maintenance, all kinds of stuff, right? Yeah. But yes, absolutely. Thermal properties, energy savings, energy costs are going up. And so... the first house that we built, we went overboard and tried to make it as thermally efficient as possible, right? What I would call a high-performance home. The homeowner contacted the builder and said, listen, I think I tripped my breaker and my heat pump hasn't been on for 5 days. Well, that was in the middle of January, and it had been 10 degrees outside, and she hadn't even noticed that it was tripped for 5 days.
Oh my gosh.
Because it was holding the energy so well. So things like that are great, if we can get them to work. And I think that's kind of where some of this is going. I think the last part of it is with this system here, not with the gantry that we were working with before, although you could try to do it. We can take this into a warehouse environment now. We don't have to be out in the difficult environment of a site. We can pre-print, we can create modules, we can stack modules.
You have some modules out there, I know.
Exactly,
speaking of aesthetics, there are a lot of interesting curves you can do it. I've noticed that the things that you've already printed, seems like it's more robust in the way that you do. I know there's some limitations that wood have over concrete, but yeah, I definitely think that there's some unique designs that can be done.
Well, exactly, and so the ability to go from kind of straightforward to customizable is very quick compared to if we're going to be framing it. Now we've got to figure out, well, how are we going to frame this out differently? What does that mean for other things? In this case, we can just start doing these different types of wall systems. You saw the piece outside that had a plated kind of a plaid kind of structure to it. We can do that as an island facade. You can do it on the back of the house and have an outdoor patio behind it. We can actually build pockets into the printing process that allow you to grow plants along the wall. There's all kinds of, and those are just kind of straightforward, early, basic things that we can do. There's so much more, and I think that's where it's going to start taking off, and people are going to say, "Oh, wow!" Even maybe with my phone, I can start telling a builder the different options that I want, and the builder options are not cove trim versus some kind of a chair rail. It's, do you want integrated garden plant pockets into your wall so you can have a green wall system? We can do that kind of stuff now, and I think that's kind of fun.
Yeah. I know you spoke a little bit about the California wildfires, but in Florida, the wind conditions, I would assume intuitively these things are structurally more sound to build.
And they handle debris flying through the air better, right? So
absolutely.
Yeah, so if we're worried about saving lives and we have flying debris and we have a 2x4 that's going at 160 miles an hour, this is going to save your life faster.
Well, you're adding less debris in the air.
Well, that's true too. They're not being sucked up as well.
Although
But
the roof system, I would imagine, is still something that you guys are exploring with concrete. Are you printing out the roof structure as well?
not yet. It just adds, that's another cost
Or
parameter.
maybe the dome. I know that in brick.
We
you know,
could,
yeah.
we could do a domed. And we've done, the way we've been working with that is you do it upside down as a planter. You build it on itself. That's, you've got to work out the concrete and the extrusion rate and everything like that. But
You had mentioned in the beginning that economically it's not there yet. But is that what you're doing here, the research? What is your hope? What are you trying to get accomplished with the people here and people experimenting?
so the funding that we received from Virginia Housing, which has been, incredible in terms of what we've been able to work with, has allowed us to have a runway. That's what I call it, a runway of about a year to kind of just prototype, experiment, try things, see what we can do. The overall goal, and that's why the 10 houses, is to see if we can start actually reducing cost at scale, right? And so I think that's where the pre-printed pieces come in. That's where looking at warehouse environments versus site environments, all of that starts to come into play with it, with that equation is where do we actually start saving more and more money? So an example, the last 4 houses we've produced, we have very good detailed data on all of it. We've identified that
And people are living there now.
absolutely, yeah,
Yeah,
and we're
you talked about the
and we're
example.
censoring, yeah, exactly.
I just think that's
we know
some
how they're
incredible
performing as
work.
they live there. We know the energy consumption exactly. What's cool about that is we identified that printing over the window, for example, it adds a large amount of cost, right? So
How do you do that? Do you add like a lintel or something
Exactly.
before you print?
So it's large pieces of metal that hold up the concrete above it, and it's to make sure that you flash it correctly and you mitigate water. It ended up being 3 pieces of large metal, and across the house it was $6,000 extra in cost, right? Plus the
Is that
concrete.
because of steel?
Exactly.
I mean, you have the same problem when you're building with brick.
Right.
You have to put lintels up. There's not a perfect science to all that.
Right. So for that, in that case, we're just taking the windows and we're panelizing them, and basically we print to either side of the window. We create panels that just get brought in, prefabricated, completely covered with a moisture barrier, and then the siding that we want to use. We could put concrete in front of it, or we can use something different to kind of break up the facade, and it goes straight from the foundation all the way up to the roof line, and it's protected, right? And so we don't have to, we're designing in these ways to reduce some of that cost. And we've been building here in the lab, we've been building test wall prototypes of that so that we can see how does that work? How do we fit it together? How can we prefabricate all those window and door elements so they just slide in? We already have the walls printed on either side of it, and really all we have to worry about is a joint on either side where the concrete and the panel come together, and that is covered with trim and then a caulk joint, So we're trying to figure out ways to reduce that cost. The transportation itself is a huge cost. So now we can take this behind a pickup truck on a flatbed, and we can get the rest of the equipment either on that flatbed or in a small covered trailer, and we can move this around for $400 or $500 depending on where we want to go. It used to be with the gantry system,
Right, it's giant.
it's
It's
an
huge.
$8,000
right.
cost, right,
I mean,
with
part
flatbeds.
of, as I recall, the way you described it to me, this is what appealed to you and the research you're doing because it was portable, and it's part of reducing the overall cost.
Correct, yeah.
And because it's affordable, people can just purchase this and put an investment, and they can keep it in a local warehouse or storage, and they can haul it with them on projects.
Right. Yeah, I mean, that's the beauty of this is it's very transportable.
As you perfect this, you're hoping that better technologies come out, the manufacturing of these become even more affordable, and so all of that is going to impact the overall cost.
Well, and you're starting to see this. Like, what's to say that this isn't a piece of equipment that can basically be pulled behind a pickup truck to a job site because we have these parts of the building that it just is time consuming, and it's something that we can do 24 hours a day. in a mobile unit on site to produce pieces that we need for the building. You have all these different sides to this that make it ultimately more transportable to the site, and all the ways that we can apply pieces of the building process that have held us back before. And that's part of the research we're doing is, here's the concept. Roboticists make great robots, and they have no idea how the construction industry works. Contractors make great buildings, but they really don't know how to work with robots. And so how do you bring those two together? This is a robot that you're going to be working with tomorrow, right? And we're going to look at all the different ways that that requires you to be a different worker. Our workforce and the future of our workforce is something that's really at the core of everything we're doing. It seems like it's affordable housing. It seems like it's concrete construction, but it's really looking at what is the future of our workforce and how do they interface with technologies that are going to make their jobs go better, faster, help their safety and help hopefully their bodies, all that stuff, but they need to know more in that process.
I just think that you're trying to create the manufacturing process in a construction setting, and this is one piece of the puzzle. Now, you've said that you've built 10 homes so far?
We've built 4 so far, 10 coming up.
Coming up,
Yep.
I got you.
Yeah.
In the 4, could you describe any more lessons learned? The good, the bad, and the ugly, everything.
So the first home, it's a little dramatic, but it's kind of funny too. The first home, we decided we were going to set up a media site,
Okay.
so that people could watch, like a platform, so people could watch us on the site because we were excited to engage the public. And it was our first job. The printer came out of the box. It was 3 months late, so we had to start printing the house almost immediately. We had like a week to learn and troubleshoot, and we failed often, we failed fast, and we recovered. And that was really the biggest learning that we've had. It was unbelievably valuable.
So all that
Embarrassing, but
all that thing, all the failures and the reset and learning, is that calculated in your initial calculations saying that, it just costs more? Is that all in that equation, or are you saying excluding that it still costs more?
So at this point, the learning has been incredible in this space, I think, in terms of contractors, right? So the difficulty is getting contractors to want to learn and fail. In our industry, I say this a lot, but I think it's true. People want to try something new, but they want to make money on day 2.
Yeah.
Right? So getting them to fail often and fail small is really difficult. They just don't want to do it. And so a lot of that has happened. So yes, that cost parity where we are is because a lot of people have learned from failure, from the failure of others. We have a pretty good community around this.
Hope.
Oh yeah, there's absolutely hope. Well, and that's the point is
failing forward, that's the concept.
Yeah,
right?
I love that. Yeah, that's exactly right. Failing forward.
Any other lessons learned? Any issues you ran into?
Well, don't make promises you can't keep. It hurts us all, right? It hurts the industry. Every time somebody gets up and says, we're going to save 50% and we're going to have 50% of the time, and they honestly, they haven't been able to hit it yet. They're saying that, I think, because they're hoping to get investment. But what happens is it doesn't work.
Yeah.
And people are saying it based on conjecture. It's a very speculative kind of environment in that way. We've gotten through a lot of that phase of the new technology and the speculative environment, and people are really saying, okay, what does it take to do this now? And so you have a lot of the people who were originally doing that, they're no longer part of this equation because it's not the same as it was, and they weren't able to make good on what they said. So now you have people who are really trying to make it work because it actually makes sense for it to work.
They see the light at the end of the tunnel.
Yeah, yeah. So that's a big one, I think, is getting past the kind of speculative side of any bright and shiny new innovation, you know? We've learned, like I told you before, about all the areas where we think there's bloated costs and extra cost and what we can do to kind of bring that down. The big learning piece that I mentioned before was you have to be a good concrete contractor before you can be a good concrete printer.
You kind of need to know the chemistry.
I think what happened was a lot of these companies wanted to be developers.
Okay.
They wanted to be 3D concrete printers who were going to be developers. And in fact, if you didn't have a huge amount of money backing you, it was tough to be even a good concrete printer unless you knew concrete well.
Because you can't control the environment. Doesn't the humidity, the temperature, all the time of the day,
if you know concrete, you can look in that mixer and you can say, okay, this is actually way too wet, or this is actually just about the right consistency where we can keep pumping it through. Wait a minute, everybody, we got to stop. That's another big thing we learned. Before, we thought, okay, if things start going wrong with the mix, and remember, we had a gantry, and we couldn't stop because the whole house, we would mess up one part of the print, and we'd lose that entire wall of the house possibly, right? So the advice we were going under was just print faster, just get more out of the hose. It'll be fine. We'll figure it out by the next round, you know. And really what we learned was, okay, everybody stop. Take a minute. Okay, we're going to clear the hose, remix, let's get it right. Let's not try to push it just because we're worried.
Slow and steady wins the race.
Exactly.
Take it easy.
Tortoise in the hare,
Yeah. Now, you're speaking of people that want to get going. You're surrounded yourself. They have excitement over this idea of concrete 3D printing. But on the other side of the spectrum, there are skeptics.
Absolutely.
You know, and what do you say to those? Oh, why do we have to change? It's too expensive. It's not as good. What do you say to that? I mean, I feel like it's everywhere in construction, right?
Sure, yeah.
That whole mindset.
Yeah, well, to me, you know, and I think of in terms often of the residential construction industry, we have an industry that is progressively getting consolidated among a few big builders, right? And you still have the people who say, I'm not doing that. I'm going to have my own business. I'm going to do my own thing. And I think we'll have room for those skeptics who say, I'm not doing this. I'm not going to try something new. I'm not going to get on board with what's working for others because I like the way I'm doing it. And it's typically a risk argument, but actually it's more of a moving and not wanting to be moved, right? Like they want to keep doing what they've been doing. They don't want to have to mess with trying new things. Yes, there's some risk that they're worried about, but I think also it's as Ivan Beliveau used to say, history, momentum, and hard-headedness, right? It's just the way we've been doing it, and I'm comfortable with that, and I really don't want to mix it up.
Talk about the human species.
Exactly, that's right. So I think we'll continue to have that and room in our industry for that. But for the groups that want to be competitive, it used to be an argument of competition. How can I afford to hire and train somebody for that or try that new innovation when somebody can just walk off my employment list and go give that talent to somebody else, or somebody else is going to come up with a better technology and it's just I'll be doing something else next year. And part of the argument there that I've said increasingly is how can you afford not to, right? If you want to be competitive and you want to actually be able to stay in the market and offer something that others aren't, you have to stay on top of some of these. It's just the difficulty of choosing which innovations, which new processes to try. That's part of our argument here at Virginia Tech is if you hire our students, you're going to get someone who's filled with a lot of these new technologies and knows how to work with them. So that keeps you market competitive as well. But increasingly over the last 3, 4, 5 years, the trends that I'm seeing, and I could be wrong, are more of an argument if the construction industry is not able to do this on its own terms, other industry will come in and do it for us.
I totally agree with that. I think you're seeing it. I see it in a lot of fields, right?
Yeah, I work with a group of electrical contractors, and I work with this visionary. His name is Fred Sargent, and Fred likes to say to them, if you look at the 1920 census, what percentage do you think of the 1920 census was wheelwrights, people who made wooden wheels? It was 20% of the employment. He said, where do you think that was in 1950? So if you're an electrician and you're thinking that you're going to be doing the same thing in 30 years right now, if you think that on the census we're going to classify you as electrician the way we did 10 years ago in another 30 years, you can't think that way.
It's change management.
Yeah.
We're not willing to change, but you're going to get swept away one way or the other.
And it's our ability to handle change and adapt, I think, that is really going to define our industry.
Yeah, and I think that's an important point. I know you know our story, Procon story, with Professor Tom Mills, and we had to workshop a lot of those things in order to get to the virtual site inspection, in order to get to where we are today. Also, we also needed technology to catch up. You know, there was a lot of different things that needed to align. But if we weren't doing the important research back in the day of figuring out, hey, there's all these emerging technologies that are all converging during the dot-com era, the internet, the wireless computing, the mobile computing, the video conferencing, all those things combining, what does the future look like? I mean, we're walking around today and it's a no-brainer. It's very cost-effective, but the important work needed to be done 2 decades before it became material.
Yeah, so how do you help grow not only the visionaries, but the champions, the people like you?
This conversation,
Well,
we need to get
that's
more
true.
people engaged. I do think that the construction industry largely has been looked at as a afterthought. Well, that's just work. That's not like cool, exciting work. I love the things we do. We impact the built environment. We impact the quality of we build schools, we build hospitals, we build the most important infrastructure that allows us to communicate or transit, go places here and there.
Yeah.
I mean, it impacts our daily lives. It's very impactful, and that's why I love our industry.
I agree, and I feel like part of what I'm enjoying with the recent need for housing is people are finally admitting that housing is a critical part of our infrastructure, right? Buildings are a critical part of our infrastructure. Yeah. Before it was how do we connect buildings, and but our choices when it comes to buildings and how they fit within the infrastructure are just as important as the infrastructure itself.
Let's talk a little bit about research and development in our industry. You and I know, we talked a little bit earlier about it, our industry is resistant to change. And they're even more resistant to bring, the type of funding that's necessary to affect change. And so I wonder maybe if you can speak a little bit to that, and you have any thoughts on why that is?
Well, some of it goes back to the whole idea of profit centers, and if you're doing, it's like being the CEO of a large corporation, you're responsible to the shareholders for making profit. I mean, that's really,
right.
That's your job. And they can argue that that's really that's the primary reason that they're there. And a lot of this industry, I think in the past especially, it's been hard to make the margins. That in turn is a vicious cycle that means we don't really have the time to try to be innovative and do research and development when we're really busy because got so much work and hopefully we're doing pretty well on our margins. And then when we go through the cycle where we're not doing so well and we're hopefully kind of carrying some people that, because we know the jobs might come back pretty soon, we don't have the money or time to invest in research and development at that point either. So it's part of the cyclical nature, but also part of the fact that I think with the materials and with the kind of capital investment in construction to do something like these large panels that you see outside, it takes a lot of money. And that for a construction company that's working on relatively, often a lean kind of margin basis, that's just seen as something that you're putting towards an item that could really actually yield better productivity for them in a different area, right? What I think that we haven't done a good enough job with is interfacing with the academy, interfacing with universities and saying, hey, these are some things that we would love to try to figure out. We have a little bit of money. How can we work together? You can be the R&D engine because we just can't afford to have that. That's where we got to do some work is getting people together. Or, hey, here are 5 companies that are interested in similar needs, have similar needs. How can we get some researchers to actually, and some students, And then what you're doing is you're getting people excited around the industry. They want to come in the industry.
Yeah, and I when I look across the industry, I do think that, first of all, I think Virginia Tech is an anomaly, right? We're one of the top programs in the country. We have a hit hall, a facility, world-class facility at the Innovation Center here. But we need more of this, right? We need to be able to scale. So do you think this is where the government kind of helps shore up some of this research? Because I know you had talked about this research that was funded by Virginia, right?
That's exactly right. So, and when you were saying
In
that,
these important
I was wondering if you were going to
research,
go
right.
there, but yeah, it is, yes,
It's
absolutely.
so important.
This is where government is an important middle, person, maker of, they basically take us where we need to go in
Just
some
give
ways.
you just enough that
Yeah.
momentum to get things started, because otherwise we're in an industry where no one's going to want to change.
Right.
We need to try things to ultimately get you to a more efficient, to produce more with less, to produce more quality work, stronger, more resilient work.
You're absolutely right. If that's the role of government, and it can be done very efficiently, I think there's a general sense that sometimes the research environment is inefficient. It's actually quite efficient in a lot of ways. There's a lot of requirement to be efficient, but the way we translate it back to industry and let them understand all that we're doing and how transformative it can be, that's where we're failing, I feel like. We have to translate this back to the industry in a way that they get and they say, oh, that makes sense. That's well worth investing in, right? If they can't invest in it themselves, we need to have ways that can happen. Now, I've said it before, at some point, this is a $17 trillion industry, right? At some point, other industry is going to say, oh, well, we can do that. That we can figure out how to make margin in that area. We're just going to get more
We need
competitors.
to be able to combine the resources
Yeah.
of people to infuse more R&D. I do, anytime I get a chance to really promote that, I do it as an organization, and I think more can be done.
I think that's
for
great.
Sure.
Yeah, it's amazing.
Yeah.
That's where we need to go.
So what do you think the future looks like?
So I think,
I'm going to hold you to it because we're going to look at this in the time. This is a time
can we do
capsule.
a time capsule? Okay.
Yeah.
All right. So a couple of things. One is when we started with our first gantry printer, we looked at that and we said, how is it possible we can ever figure out how to use this thing? Now we look at that as a dinosaur, right? Things are getting smaller, they're getting more efficient, they're getting more accessible, they're getting less costly, right? This machine is a fraction of the cost of what we paid for the gantry originally, and it's just getting better and more accessible that
I
way.
think of the plasma TV. I was just having a conversation with someone about that.
Yeah.
Do you remember how much, like, if you bought one plasma TV in the 90s, or maybe it was like early 2000s,
Like $1,500,
$2,000,
$2,000.
like it's ridiculous. And you could, somebody was foolish enough to pay like $3,000-$4,000.
And these are smaller too, right? Like
Yeah.
they're not even the huge ones.
Right.
Yeah.
Now you go to Costco, you get something really thin for like $300, and you're like,
This is
you know.
great. Yeah.
But I agree with you on that concept. I think we need R&D, we need capital to be able to do things better.
Yeah. Okay, so the future then, the next part of the future, I think is, like I mentioned before, the worker. I think we're going to see that that's going to change a good bit, and the talent,
We have a talent shortage,
we have a talent
which
shortage.
we didn't talk about as one of the benefits, right?
That's true. Yeah, labor is a big part of this.
Yes.
But the goal here is not to replace labor, it's to bring the skills of labor to the point where they can use these technologies that benefit the overall construction process and produce more buildings faster, that kind of thing, less expensively. Because we're seeing that even though we have a huge need for labor, we're not getting enough people into the industry. They're not coming into the industry. So we're going to have to fix that. We're going to figure that out. And I think the future is going to be a little bit more automated than it has been. In fact, quite a bit more at times, So technology and people who know how to use it will replace people who don't use technology. I'm not the first person to say this. I think it's Sam Altman. AI is not going to replace people. It's
Right.
people who know how to use AI will replace people.
Right.
And I think that's a lot of where we're going as well.
And it's going to be slow. I don't think that, it's not going to.
We still will have a lot of room for people who...
We have a labor shortage
Yeah.
at the end of the day, right?
Yeah, that's true. Yeah, so I think that's where we are.
The one thing that I do want to just ask is, like, how has this center here? Because I know when I was doing research back in the heydays.
Oh, man, what a difference, yeah.
We were in, like, the broom closet of Burris Hall. And
Yeah.
a facility, I'm still at awe with this huge facility and your ability to have students experiment with this type of equipment. How has that been like?
It's been amazing. It's been amazing. It just takes the work that you're doing to a different level. So in the Center for Housing Research, one of the things I love is all the houses we're building are going to families in need, right, who can't afford housing. All the work we do is based on trying to help people who wouldn't be able to have options for their housing gain options. So we get a lot of that gratifying, thank you so much. This is, impactful work and it helps us. Here, it's a different feel. It's because we're surrounded by people who are interested and want to get involved. And so they come in and they just want to be part of it. And I love it at Virginia Tech. The culture is already kind of that I may serve, serving others. But it's much more that I may get involved, right? It's really, and it happens every Friday. We print every Friday. We have students who want to come in and get involved, or how can I be of assistance? I just see people in the hall and they'll say, hey, listen, if you're ever printing and you need an extra hand, I'd love to do it. So I think what you'll see tomorrow is there's an energy, there's an excitement. I mean, there's going to be times where we're kind of trying to figure things out and we're kind of waiting around, but the people who are swirling around the outside and looking in and checking out what we're doing are going to be plenty. And that makes it more fun than being in some room where the door's closed and you're running some experiment and nobody really understands what's happening. It also means that I think they're getting exposed to a side of our industry that they wouldn't normally see as exciting. And that's part of what this building is doing, is it's allowing us to get people who might normally see the industry with a different perception and say, okay, now this is kind of cool. I could see how I could be in that industry now.
Well, I'll give you the last word. I think we're at the end of our discussion here. And any lasting remarks that you want to leave to the audience?
Well, just thank you for everything that you've done for this industry, for you and the people around you and the organization that you and Mark have worked hard to make. It is uncommon, I think, but also hopefully it's becoming more common. We'll see. But it's a legacy, and I think we need more people who see that vision and want that legacy. It's something to pass on, right? It's to pay forward, and I think our industry is a great place where we can do that. We can tackle all of the different challenges we have now, but also we need to be forward-looking, not just paying it forward, and you're a great example of that, and you're living, right, what you preach, and that's really important in the world, and thank you for that. It's been great to know you and to be someone that, that I can come talk to and call you my friend, and, I really appreciate that.
Well, Andrew, I so much appreciate the compliment, but I'm going to throw the compliment right back at you. The important work you're doing here, the impactful work you're doing for affordable housing, technology, innovation, and everything. Really appreciate you. This was a lot of fun to have this conversation. I hope to do it again. So thank you for that.
Well, when I say this, I mean it. It is my pleasure. Yeah, great.
Awesome.
Thanks for
And
having
that
me.
wraps it up for us.
Here we go.
All right, take. Hold on, come on. We need to take 3.
For real this time.
For real.
Take 3.